Quiz 1 solutions for Math 111. Let's see the first problem in part A. We're just asked to evaluate and simplify this mess right here. Kind of like a fraction over a fraction, but not quite. If it were a fraction divided by a fraction, we know how to deal with it, but it's not, which is unfortunate. But we can simplify it so that it becomes a fraction over a fraction. Let's see, 1/2 plus 1/3. You have different denominators. So what you got to do is find a common denominator. The way I think about it is you can only multiply by 1 without messing things up. So over here we'll multiply by that form of 1. And over here we'll multiply by that form of 1. And the reason we chose those forms of 1, I haven't even gotten to the denominator down here, is now we'll have the same denominator in the top of this fraction here. We got 3/6 plus 2/6. And then down on the bottom here you got 1 minus 1/5. Again, you don't have a common denominator, but you can think of 1 as 1 over 1, or even 5 over 5. 5/5 minus 1/5, that's just 4/5. And now that we have the same denominator up top here, 3/6 plus 2/6 is 5/6, and still 4/5 on the bottom there. And so it might not look like we've done much, but this is much better than this, because this is a fraction divided by a fraction. And a fraction divided by a fraction is something we know how to deal with. It's a lot like multiplying fractions, except you multiply by the reciprocal of the denominator. So instead of 4/5, we got 5/4 here. And now we just need to figure out what this is. Let's see, multiplying fractions. 5 times 5 is 25. 6 times 4 is 24. And that there is our answer. Put a box around it or something if you want. All right, moving on. Part B. Express this thing in interval notation and graph. I mean, I guess you could argue it's already an interval notation, but express it as a single interval in graph is really what we're going for here. I think this is the exact example we did in class, same numbers and everything. If not, it's pretty close. But anyways, what I'm going to do is I'm going to graph each of these sets individually. You do not need to do this. But I'm going to do it just because it might help in case you weren't sure how to do this problem. So let's see, 0, there's 4, -1 out here, so we kind of have an idea of where things are. Our first set is everything from -1/3 up to 4. So it ends up here at 4. And note I'm coloring that dot in because we have a closed bracket here, so we want to include 4. And it's everything from -1/3 up to there. So -1/3 somewhere in here. But note I leave this circle open because we don't want -1/3. What we do want is everything in between those 2 points. So something like that. And if I do the exact same thing right below it, let's see, there's 0. Here's 4 out here. 5, 6. -1 in for reference. The second set is everything from 0 to 6. Alright, there's 0. There's 6. Note they're both open circles because these are both parentheses. We don't want to include either endpoint. We do want everything in between. So okay, I've graphed this set and I've graphed this set. Now I just need to know what this thing right here means. This is our intersection sign. The intersection of two sets is everything that's in both this set and this set. So let's see here. Looks like it's everything from kind of right here up to right here. Yeah, more or less. You don't want things less than 0 because they're not in this set. We don't want things more than 4 because they're not in this set. So if you kind of analyze what we got there, you would say that this right here is everything from 0 up to 4. No, you don't want 0 because 0 is not in this set, but you do want 4 because it's in both of the sets. So this right here is our answer, and it asked us to graph that. So, all right, getting a little overboard with the graphs, but I can still do it. 1, 2, 3, 4, 5. There's 5 out there. 0 to 4, it's not including that. That is including this, and it's everything in between. So really all you need is the stuff to the right of this line for your answer. This was just me kind of explaining what I was doing. Maybe a little overkill. And that's the end of the first problem. Second problem, evaluate and simplify these 4 things. Kind of dealing with some radicals, some of the rules we learned. I think these will look pretty similar to some examples that we did. say this first one, the square root of 18 plus the square root of 2. What this is not equal to is the square root of 20. You can't just add those numbers together. In fact, there's not a whole lot we can do with adding square roots together unless they're the same square root. And so you're like, all right, 18 and 2 aren't the same. And I'm like, yeah, but you can think of that 18 as the square root of 9 times the square root of 2. And what's nice about this over here is the square root of 9 is just 3. So really, this is just equal to 3 root 2 plus root 2. And then you're like, all right, I got 3 of these root 2 things, and now I got 1 more of these root 2 things. That's 4 of these root 2 things. In other words, my answer is 4 root 2. Good enough? This one's very similar. Maybe I can even cheat a little bit. Using what we did in part A, we know that this is 3 root 2 minus root 2. Yeah, this exact same analysis, except now we have a minus sign here and here. 3 of these things minus 1 of these things is equal to 2 of these things. Good enough? Multiplying them. The rule you're using here is a to the x, b to the x is equal to ab to the x. And you're like, wait, what? There's no exponents here. These are all radicals. Yeah, okay. Well, really, this is 18 to the 1/2. And we're multiplying that by 2 to the 1/2. And you're like, we have different bases, a and b here, but the same exponent. So what this is equal to is 36 to the 1/2. 36 being a times b. And then you're like, wait, but 36 to the 1/2 is the square root of 36. And the square root of 36 is just 6. And so that's your answer right there. And then finally, the last one, square root of 18 divided by the square root of 2. I think the way I would do this is write it like this. And then using this rule again with the a is 18, the b is 1/2, and the x is actually 1/2 too for the square root. But the b is 1/2 because it's kind of, the 2 is down in the denominator. But anyways, using that rule, you get this, which is this, which is this. 18 over 2 is just 9, square root of 9 is 3. I think when we did this one in class, I said there were 2 ways to do it, so maybe I'll do it the other way too. The other way would be to say, oh, root 18 is just root 9 times root 2, as we've seen already. So root 18 is root 9 times root 2, but now we can cancel out those 2 root 2's. We're left with root 9, which is just equal to 3. I didn't really put boxes around my solutions. Maybe I should do that. Although I don't know if you need to keep watching the video to watch me put boxes around the solutions. But I guess if you made it this far. But that's the end of the quiz. That's the end of the quiz.